Okay. How do we find the area of a rectangle? L times W. You've always been taught that L is the longer side, W is the shorter side, E's, B's, lemon squeezy, yeah? Because if W is 2 and L is 4, the area is 8, right? You already know all this. Hey, Manru, go sit back by Sahil. Just go sit back by Sahil. And Anu, you're going to sit where that Sahil is, and that Sahil is going to move over to your desk. It's nothing personal for you, man, but there's 30 kids in the class. I got to split up these 4 before I put something in their somethings. Because I can't take them anymore. So... That's your desk for a while. You'll piss me off there too. Then I don't know where I'll put you. I got one desk in the hall. That'll be the first step. And then I don't know where you're going next. So, length times width. 8. E's, B's, lemon squeezy. What if it's a square? It's still length times width. Except what? Length equals width. So do we need 2 different letters? No. So we need how many letters? 1. So it's really L squared or W squared or any other variable squared. Right? Because S and S are the same. Now, if you're provided with the area of a square, we know that area equals LW, but we know that it also equals S squared. So if you're provided with the area, how do you determine the side? Of course, it is square root. Square root both, and you get side. Now, this is why we call it a square root. That concept is important because a great many of you don't seem to actually gather that that is the relationship. You all can tell me everything I want to hear, but you all seem to have trouble with the actual understanding of the relationship. This symbol right here, and I've lost my little highlighter. This symbol right here is the radical symbol. We are going to use a lot of it. It is asking us to find groups of identical factors. Now, this specific one, because area equaled S squared, which also means area equals S times S, yes? S times S, those are factors, yes? They're the same, so that's why they're a square. This symbol is asking me to find groups of identical factors. The symbol itself just means you're breaking down into factors. All right? There's more information that goes with this symbol that tells you what type of factors you seek. But right now, you just need to know that symbol. The radical symbol means you're looking for a certain amount of groups. A certain amount of factors in each group. Okay? All right. How do I find the volume of a prism? LWH. Volume equals LWH. What if it's a cube? Is it still LWH? Of course it's still LWH. Except now L equals W equals H. So I don't need LWH, I need S times S times S, or S cubed. Right? So, being the intelligent young people that you are, if I have the volume of a cube, that equals S cubed. What do I do to find what S is? I take a cubed root. Yeah? Now, I only have 2 drawings for this. You're intelligent young people. What do you see as the difference between that and that? Jesse. There's that little 3 there. Okay? that symbol, we know that symbol is asking us to do what? To find groups of identical factors, yes? And those identical factors in this case, s times s times s, right? This one is asking us to find how big a group? Group of this one up here. 2. This one up here is looking for a group of. So the symbol doesn't change, but that little number does. That little number is called the index. Please highlight it, underline it, put a Mrs. Bag Crumble cloud around it. I don't care, but you need that word. The index tells you how big your group must be. All right? So, when there is no index, how big is the group? 2. Now, this is weird. Normally, what's the number that we very, very rarely write in math? 1. We very rarely write 1. We don't write 1x. We don't write x to the first power. We don't write 4 divided by 1, 4 over 1. We just write 4, right? So usually it's a 1 we don't write. But in this case, we don't write the 2. Why? Because this symbol means we're looking for a group, yes? Can you have a group of 1? No. So there will never be a 1 there because you can never have a group of 1. Okay? Okay. So obviously if there's a little 3, I'm looking for a group of 3. If there's a little 4, I'm looking for a group of 4. What if there's an x? I'm looking for that many factors. Whatever that number is, that's the amount of factors I seek. Everybody cool? In grade 10, we don't go much past 5. Okay? Now, a perfect square, a perfect cube. Now, there's arguments as to the definition of a perfect square, a perfect cube. For you people in the 10th grade, we are going to say a perfect square, a perfect cube is a number with an integer square or cube root. Okay? It's got to be an integer. Everybody cool? So, for example, square root of 4 is 2. 4 is a perfect square for our arguments in this class. All right? Square root of 9, 3. Easy peasy. Cube root of 8, 2. Cube root of 27, 3. Everybody cool? For our purposes, we are going to say it's got an integer square root. But you could argue, for example, the square root of 1.44 is 1.2. Does that make 1.44 a perfect square? No. Yeah. By our arguments, no, but in reality, is it? Yeah. Sure it is, because this is rational. Everybody understand? So the real definition is if the root is rational, it's perfect. But that makes our lives slightly more difficult. So for our purposes, we're going to say it's an integer. Everybody good? All right. Now, square roots, cube roots. Yeah, turn the page over. Square roots, cube roots are so useful and so important to higher level math that they're almost like the times tables to now. Okay? Like, if you can do your times tables in your head without thinking about it, that means you can also do division in your head without thinking about it. And how easy is Math 10 so far if you can multiply and divide in your head? it's not too bad. These become that next year. Do you understand? So make it a point of at least memorizing this much. I would recommend more, but that's up to you. Okay? We're going to do something with it in a minute, so we're going to do this together right now. We're going to put the squares on top and the roots on the bottom. Now, there's going to take up your whole page, so don't write big. What's the square root of 0? 0, because 0 times 0 is 0. 1 is the square root. What is the square of 1? 1. 2 is the square root. What's the square of 2? 4. 3, 9, and so on. Until you get up to 400 up top. Most of you already know what it's going to be. Now, when you get to 12, most of you are going to be in trouble. Right? Most of you are probably going to grab your calculator for 13 squared. But you don't need to, because like everything in math, there's a pattern. Notice, the first perfect square is 0. What's next? 1. How much did I add there? 1. The next perfect square is 4. How much did I add there? 3. Then, oh, that's 100. Then 19, then 21, then 23. So what would I add here? 25, 169. Then what would I add? 27, 196. Then what would I add? 29 to get 225. Then 31 to get 256. Then 33 to get 289. Then 35 to get 324. Then 37 to get 361. And then 39 to get 400. Everybody cool? Now all of you should notice a few other patterns in here. Right? For example, let's look at the easy one. What's the square root of 100? 10. Agreed? What's the square root of 400? 20. Okay. What happened from 100 to 400? It was multiplied by 4. 100 times 4 got me 400. Yes? Okay. The square root of 100 times 4 and the 400, square root of 400 is 20. Yes? So therefore, what is this square root? What is the square root of 100? 10. What is the square root of 4? 2. Everybody see?
Hold on.
Okay, I'll show you again. What is the square root of 64? 8. Agreed? Okay. What is the square root of 8 breaks down into, we've just done factoring into what? 4 and 2 would be what most of you would do, right? It's really the only one you do, because why would you do 8 and 1, yeah? Okay. What is 4 squared? 16. What is 2 squared? 4. What is 16 times 4? 64. 64. 16 times 4. What's the square root of 16? 4. What's the square root of 4? 4 times 2 is 8. Does everybody see what is happening here? Smaller squares are used to build up to bigger squares. And notice, all of this is multiplying, yes? Which means it is all related to exponents. Everything cool? Great. Now let's do the same thing for the cubes. We'll put the cubes up top and the roots on the bottom. The first few are easy. 0, 0, 1, 1, 2. What's 2 cubed? 8. 3 cubed? 27. We just did that on the back page, right? 4 cubed? 64. 5 cubed? 125. 6 cubed? Now we're in a bit of trouble. 216. 7 cubed? 343. 8 cubed? 512. 9 cubed? 729. And 10 cubed? 1,000. I would recommend committing those to memory. Everybody cool? All right. Now, let's go! But I mean, let's go.
Done.
Sweet. Okay. Is 72 a perfect square? No, it's not on our list, right? What is the perfect square to the left of 72 on the number line? Root 64, which is 8. What's the perfect square to the right? Root 81, which is 9. You're intelligent young people. If the square root of 64 is on one side, the square root of 81 on the other side, and the square root of 72 is in the middle, then where must the square root of 72 lie? In between 8 and 9, yes? Now, how far is it from 64 to 72? That is 8 steps, yes? How far is it from 64 to 81? "17 steps, yes? 72 is 8 out of a possible 17 steps, yes? So it is 8 and 8/17. Now, what is that fraction really close to? 8.5, right? Which for us on our calculators would be 8.5, right? What's square root of 72 on your calculator? Square root 72, 8.49. Good rounding, everyone. 8.49. Is that awfully close to 8.5? Yes. What's this one going to be? No. 169, which is 13, and 196, which is 14. So, how many steps was that? $11 out of a possible 27, right? What is that awfully close to? 1/3. Is it a little bit bigger or is it a little bit smaller than 1/3? Little bigger. So what's our decimal guess? 13.4. Let's check. 11 divided by 27.4. So 13.4. Everybody see how to do it? It's easy peasy lemon squeezy, right? What's 300? 17, because that's 289, and 18, because that's 324. So it's 17, and how many steps there? 11 out of 35. What's that awful close to? 1/3, 'cause 1133, right? So 17 point what? 3. Is everybody cool? Do you think anything changes on D, E, and F? Yeah, something changed. What? We're using the cube list now, aren't we? Does our method change? No, of course not. The numbers are just bigger. Right? Go. Class is over in 5 minutes. Listen to me, please. 1 sec. Ignore these instructions on 122. Everything on 122 is either a perfect square or it's not. Okay, here's what I want. I want you to use this knowledge to estimate the irrational ones. If they're rational, you tell me the square root. You should be able to do this whole page without a calculator. Everybody cool? The next page. The next page, you follow the instructions. Now, some of those numbers are gigantic, but I showed you a couple of patterns. See if you can figure out this page. Again, as little calculator use as possible. Okay? Everybody good? Am I asking you to get all these right? No, I'm asking you to attempt them. I have no idea when the fire drill will be. I do not know if it will be in the block change. If it is in the block change, it's a lockdown first. So you go into the first room that you can go into. If it happens in a block change. Then, when you evacuate, you go to your block A teacher on the field. So you would go out there as if it were a fire drill for block A. Okay? But I have no idea if there will be a drill in this break.
Sounds good. It's a really unsure answer.